Okay, back in the day when we had this class live, we would show this little clip from Indiana Jones. When he goes up to that gold statue, he takes sand. He's got a bag of sand, and he's got do we have it in the next picture? Yeah, right here. In other words, see, he takes this bag of sand, he dumps some sand out of it, puts it in. It's not the same. Well, we don't know if that's a solid gold statue. If it's hollow on the inside, that might be about right. But if it was solid gold, no way. Because gold, the density of gold is 19,300 kilograms per cubic meter. Gold's, and so when it's here on Earth, it's heavy. It is heavy. All right. And we do this little experiment in our physics class. Well, you can actually touch the wood. You see, the wood is 500 kilograms per meters cubed. We have a lead brick, which is 11,000 that we use for the thing. And the mass of something is the density times the volume. And we use that to find why things float. Lower density float higher and less density. And we're going to do this problem. We're going to figure out, in fact, why don't we do it right now? Why don't we do it right now? Okay? I want to know, and then when you come to this problem, you'll go, oh, okay, I've seen this, because and I think this is where we can stop for the most part. I mean, there's a lot of stuff on these slides that we haven't covered. Just want you to know that. But I think we can stop here. As a matter of fact, we're not going to do this problem right now. I'm going to go ahead and go into the homework, and we're going to start looking at solving at just doing the homework help part of our exercise here. But have you ever noticed how freaking hard it is if you've got a big old beach ball at the pool to get that thing underwater? It's really hard, especially if it's a big beach. If it's a huge beach ball, there's no way you're going to get that thing underwater, because the buoyant force that's pushing up on something. Let me get through all this. Okay. Oh, and the sulfur hexachloride. Okay, it's 5 times more dense than air. But anyway, let me go to the. Here's the. Do I have something on buoyancy here? Okay. I don't think I talked actually about buoyancy. Sorry that you're having to see all this stuff. Archimedes buoyancy force. Here it is. Here's buoyancy. Why things float, or why things float. Okay. There's an upward force on it. Okay. Depending on, okay, the buoyancy force is the weight of the displaced air. In other words, this bunch of helium here, or actually you can use with hot air. That's why they call them hot air balloons. And if they're helium and you heat up the helium, then they're even less dense, so they really float. But it pushes all this air out. And so because all this air is being pushed out of the way, it has a lifting, it lifts up on the object. The balloon weighs less than 8,217 newtons, it will float. If it weighs more, it will not. And the buoyancy force, if you hold a brick underwater, it's the same, because it's isometric, all the forces, Okay, so I think we've covered everything. There was some cool stuff there that we missed. Like I sometimes would spend a lot more time on it. Talk about the Hindenburg. It was filled with hydrogen. We don't know exactly what happened. It looks like it crashes into this tower here, but that's not true. It had something to do with the lines coming down. It was kind of stormy. There was lightning in the area. A lot of people smoked back then. Like everybody. And so any one of those things could have happened. The Hindenburg is one of the famous newsreels of all time, and you can look it up on your own. Okay, let's get to the homework.